Hello, Hong Kai.
Hello, Mike.
Whoa, you got a nice place. Is this a wait, is this actually your house or is
Living
this a
room.
picture? Is this your house or is this a picture?
My living room,
Oh my
a
god.
house, real house.
Oh, oh my god. Oh my god. Look at my room. It's a white wall and a window. That's it. Oh my god. Okay. I thought it looks so nice. I thought it was those like pre-render background. But thank you for your comment on the proposal. I added you as the as a participant.
Okay. I just register account for the Zoom. Let's see if I can raise my hand this time.
By the way, I don't hear anything.
Hello.
Hello.
Can you
Hello.
hear me? I can hear Laura.
I can hear people. Let me Spritzer, we can hear each other. Your cry for help was heard. Jeremy, I know Stephen isn't coming for today, so
Let's get started. It's 3 after. I don't know, Laura, do you want to drive through the scrub?
yes, I will drive. And let me join a SIG MC really quick. Okay. Welcome everybody to SIG Multicluster. It's Tuesday, May 13th, 2025. We are going to start with a scrub because we do that now. So I'm going to share the screen and lead that. Here we go. Here's the screen. Okay, so it looks like we have a list here. To be honest, I didn't write this list. I'm cool. I like it, but just for future purposes, maybe we can get some sort of system of how this stuff gets added or not. But I'm just going to start from the top and then go down, and then we'll just like see what's up. Okay, we have a PR that's about updating cluster property API to beta. This was opened last year. It was rebased in March, which there had been some other related stuff that had merged, so that is good. Thank you for rebasing it. There's a couple comments in here, but otherwise, I don't think we have either myself, who initially reviewed it, or Jeremy, who was planning on approving after that, commenting yet. So I think that's the next step. Should I do something like put like, like some triage notes? Is that too much for like a scrub? This
No,
is
I
our,
think
this is our,
that's a good idea.
I'm just making it up right now. This is what we do on call. So, so yeah, I'm
So
interested in knowing if,
yeah, I see this as a change that we want in. There's a couple questions, they're good questions, but given that it's been 3 weeks, maybe we merge, and then if we want to clean up the stuff that's not necessary, we can do that.
yeah. Interested in merging and then opening new PR if there are specific things to clean up. Okay. Yeah, and maybe while this is happening, I'm trying out this. If we like feel that this is too much for like the group scrub or something, we can change that either now or in the future. Okay, clean up duplicate CRD files. This is an issue that is assigned, but doesn't have an associated PR. I do think that we talked about this on Slack sometime in the past, so I think it would help if I could to grab the Slack thread where we talked about this and confirm that that information is still in this issue. Also, is this still in progress? I think this is the question for this one, right? Okay. Should we consider this initiative dead? I say no, but has it, okay, blah, 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 C18, is this abandonware? If yes, why? If no, how do we move it forward? Fair cue, Everard JB. But I would say as a SIG, we're still, like, this is still our project. Scream now if you disagree. Project, we have added some scrubbing. This is literally happening in this call right now to our SIG-MC call to try and catch up with our projects faster.
Not dead yet.
Yeah, not dead yet. Okay. Add well-known property ladder. Okay, this was something that Ryan opened needing some comments about. In particular, this had once been part of a larger proposal that included both the process. Let me actually go to the files changed. The process of how things should be proposed and properties. Now this PR is only about the process. There's some comments in here. But I think some of them are quite like serious in terms of like, what does it mean to have quorum or what does it mean to vote and stuff like that. So I think we definitely need some more insight if anybody has any opinions about this. So I think this one is still available for some comment, but leads, I think we're gonna need to make a call on like when we are done waiting for that, for this in particular, because it's about government. So we can't like proceed without it. Still open for comment from folks on the governance perspective, need lead input, final input as well, and we'll need to put a deadline on it next. Let's negotiate the deadline on it next time. Okay, moving on to the MCS API. Sorry if I'm going too fast, but I also don't want to take too long. Move service import spec fields. Okay, so this is the new PR from a prior PR about taking things that were in the service import spec and moving them to root. After opening this PR, we ended up having a long conversation on Slack about whether this was right or not. I think we got back around to we do want to do this, but there were some questions about what the migration pattern should be and exactly like what steps that should occur in, whether this is a V1 alpha 2 or
I lost the audio. Is everyone still? Can everyone still hear?
I can't hear
Yes,
you.
same.
I lost Laura, I think.
Yeah, I guess we lost Laura.
Can you all hear each other?
Hi.
Everybody, and then I
Yeah,
restart. It all works.
Sorry, can you guys hear me now?
Welcome back, Laura.
Yes.
Oh my God, my phone took over my headset. And then I was forced into a spam call, you guys.
Classic.
And I was
Brutal.
like, it was brutal. And I was talking about moving the service import spec fields to this random spam person. Okay, sorry, that was really exciting.
For the record, you'll say you're going more to spam calls than this.
Oh my God. That was so weird. Okay, I see that it had a needs rebase. Did that get resolved? Yes, removed. Okay, so yeah, I think that this maybe I don't know if Mike is on the call, but as far as I understand, I think we got back to the point where we agree that this is what we want to do, specifically that we want it as a V1 Alpha 2. There's some later steps about like how that gets promoted to the next stage. But I think this PR is still like correct as it is. So that's my understanding. So as far as I recall, this PR is still.
Well, I mean,
Is
we
that
didn't
correct?
really-
Do you disagree? Okay.
We didn't really like
Okay.
say anything on the thread.
Okay. With the Slack thread to make sure that this is the correct format, I guess, of the PR regarding the content change and I think it's less about the content change and more about
Well,
what
I'm still advocating
API.
for like only moving the IP to the status. But
Oh,
yeah.
I see. So it is about the content change too. Okay.
It's about everything.
Okay. Okay.
We
So
agree that we can change something and that we will mirror things.
Okay.
But the how and what
destination. Okay.
is a bit blurry.
And about what version of API that should actually be under. Okay, thank you for speaking up. So this is, how do I do this? Hold.
What does hold mean?
What is the one? I mean, it's just like it doesn't merge, but I don't know that it will have a material effect on us, but I just wanted to give it more like labels
is
so
a
it's
thing.
clear. Hold is
Yeah.
totally a thing. It's something like hold. We'll find out if it's literally this until we confirm with the Slack thread that this
Yeah, I think it
is
makes
the
sense.
correct PR for people to review. Yeah, I basically just don't want people to be like thinking we need to review this right now if it's not like that. Okay. Alpha Beta graduation is waiting for this, but is kind of waiting for the new version of it. So I think I should actually update. I can't do that because I don't belong here. The new PR that this is now blocked by is blank. Can you update the OP? That item instead. Sorry, I just did all of that in my brain without saying anything out loud. But this is the umbrella issue for the beta graduation for the MCS API. Everything has been checked off except this PR to collapse spec/status, which is the one that we were just talking about. This is the new PR that supersedes the prior one, whereas the prior one is what's actually linked in this issue. So that's why I added a note that to update this umbrella issue to reflect reality, this is actually now referring to this. Okay.
I wonder if we could
Yeah.
have this triage group, and Arthur, it seems you have strong opinions here as well, which are great. Either on Slack or on the PR or wherever, aim to have a stance on this by next meetup next week. And then we can either reject or merge or have a pointed discussion.
Yeah. So I wanted to collect at least from the implementation that are active in the SIG. If for them it makes sense or not to only move the IP to the status. For instance, for Cilium, it makes sense in a way. But I don't know for all the implementation, and because we have implementation, I think it's relevant to like collect this data.
Yeah. Okay.
And if like, I don't know, 1.2 implementation, it just diverge a lot from this and it does not play well, we would just do the merge to the spec then, I guess.
Okay, yeah, Arthur, do you mind doing me a favor and either now or off this call, can you ping on that same Slack thread and be like, we talked about this in SIG-MC and we want to have a real proposal by next week. So get it together.
Okay.
That would help me out.
I think I might do a schema explaining why it works in Cilium too.
Yeah, that would be great too. But yeah, at least the like
Perfect.
ping so that everybody on the thread knows is also great. Okay, I don't know. Am I supposed to click this? Or is this the KEPs? I think this is saying that this is the heading. Okay, here we go. This is the heading, but there isn't anything to scrub right now as I think what is being advertised to me. So I'm going to move on to KEPs because these have some specific ones. Okay, we have one here, add a derived service annotation on service import. So to be clear, this is on the MCS API KEP, and we're trying to add a sentence that this derived service annotation should be added if you're using derived services as your implementation. I honestly don't remember anything about the conversation about this, but
yeah, so the context was to facilitate like gateway API implementation and things like that.
Okay.
Because for us, like Cilium gateway API implementation is like, I don't know, 100 line of change versus, I don't know, 2000, something like that. If we don't have that.
Yeah. Last time we discussed this, I think my biggest feedback is I'm not sure this needs to be part of the spec. And I'm not against it. I mean, actually, like GKE does the same thing, but unless derived services are a requirement, it seems weird to have the spec reference the annotation.
Okay.
So maybe this needs more feedback. I also wanted to just time box the
Yeah,
script. We have a
sorry.
bunch of
I
topics
know.
today. No, this is
Yeah.
good. We're like 15 minutes in. Maybe
Okay.
we
All
bump
right.
whatever's left to the top of the list for next time.
Okay, yeah, that is a super fair point. I'm just going to write this because that's as far as I got in the thought process, and we will move on to Mike, who has Cube Stellar to talk about. And I will also make sure that you can share your screen, which you should now be able to do. Feel free to do that.
All right, let me give it a shot here. Share. I think I'll make it simple and just share the whole screen because I'm going to be flipping around between things. So let's see. What is this? Requesting private window picker? What? A screen, yes. Oh, all right. Can you see my screen now?
I can. Your desktop's freaking me out, but yes.
Yeah. Yeah, okay. All right. So yeah, so this is a project that I and some other people have been working on for a few years now. We started with an interest in so-called edge computing. We got involved with KCP and realized we were doing, they had a thing called transparent multicluster, and we realized we were doing a different kind of multicluster. So we made our own project. It's now independent of KCP, and we've moved it, in fact, to be something that can be layered on top of OCM. So let me talk about the kind of vision and use cases we're talking about here. We're talking about managing mini clusters that operate independently. This is one distinct use case in the general multi-cluster world, right? We're not trying to provide the illusion of one big cluster. We're not even trying to support any kind of communication or cooperation of any sort between the managed clusters. It's not our job. It's not forbidden. It's just not our job. I'm a big fan of modularity. So this takes a management paradigm, not a scheduling paradigm. So again, think of something like an enterprise, like a telco, that wants to manage what's on its vast array of equipment that is hugely distributed across the country or world, or a car company that wants to manage the stuff that's deployed in all its vehicles. So what goes where is described by policies, not a scheduler. Of course, a scheduler could maintain policies or the labels on objects that policies are sensitive to. Again, this is a modularity play, but the primary focus and mindset is on managing multi-clusters. And also we imagine that the workload may be layered. Again, think of those examples. You typically have a layered stack that is being managed. So you've got multiple different groups that are managing different layers. You've got different alternatives at different layers. There's a lot of modularity and flexibility. So the selection of what and where are based on predicates rather than sets. So we don't use a concept like cluster set. We use selection based on properties of clusters and properties of workload objects. As I said, this was born with a concern for edge computing, which can go to very large numbers of managed clusters. We did some prototypes that went to 1 million managed clusters, but that's not what the current code does. But it is with designed with that kind of thing in mind as a future growth direction. So one of the tricks is when you get to a non-trivial amount of managed clusters is the reported state gets huge. We do imagine that in the center you do want to get some idea of the reported state, but you can't just copy it all back because it's just too big. So in general, you want to do some kind of aggregation, and we support that. There's also an interesting special case where, in fact, what you really are doing is dispatching for each, say, pod or deployment object or whatever. You do want to deploy it or dispatch it to exactly one managed cluster. And in that case, you can do one-to-one return of reported state using the usual Kubernetes schema in the status part section of an object for those that have it. But in general, you have to do something else. So some of the features, we do unbundled workload description. So we don't use manifest work. We use just regular Kubernetes objects. So the idea here is that out of the box, this plays nice together with the rest of the Kubernetes ecosystem. For example, you can set up your Argo CD or Flux CD or whatever to deliver your workload into your workload description space. And in the case of one-to-one reported state return, you can also have ordinary stuff in the ecosystem consuming the returned reported state. We work with multiple, or Kubesteller will work with multiple workload description spaces and multiple inventory spaces. Again, this is designed both for scalability, modularity, potentially even multi-tenancy. The architecture is in terms of space roles. So one thing may play multiple roles. So you can have very compact deployments or very large articulated deployments. Let's see, this currently uses OCM for transport. We originally had our own transport, but we decided it was a better strategic bet to layer on top of OCM. We lost a bit of functionality in doing that, but it could be recovered as an OCM extension. And we also, this is it's a modularity play coming up later. So yes, this next point, we do have an architected boundary between the upper layer and the transport layer. So OCM is not the only possible transport. As I mentioned, I think in some earlier meetings of this SIG, we imagine potentially doing other things, such as a hierarchical transport or using a CDN to distribute desired state. Let's see. And then for the reported state aggregation, it is designed to look a lot like SQL grouping and aggregation. and specifically even so that it could potentially be re-implemented to use SQL grouping and aggregation. So I've been using this word space. I need to stop and explain that because that's a really key concept here. So we have this concept of a space, which is a thing that has the part of the behavior of a Kube API server and the associated controllers. So in particular, it's the generic part. So this, and by generic, I mean it's not specific to containerized workloads. So we're not talking about pods, services, all that other stuff that is specific to that kind of workload. But there are also some generic things in kubesteller. I'm sorry, in Kubernetes. Namespaces, RBAC. There's things like in terms of controllers, there's a generic generic object garbage collector. So stuff like that is what we mean. So again, the space is a concept or a role, and different things can play that role. The kubesteller interface involves two kinds of space roles. One is used for describing workload. We call it a workload description space, and that is to say, it holds these regular, ordinary Kubernetes objects that have desired state and reported state. And we also define a new kind of object to hold the aggregated reported state. And then the other kind of space role in the interface is an inventory space that holds the inventory of the managed clusters. The implementation uses two kinds of space role, again, the workload description space, and we combined together for practicality the inventory and transport spaces into one space role in the implementation. All right. Next key thing is a separate project we call KubeFlex. Kubesteller uses KubeFlex as its provider of spaces. The connection is fairly thin. The Kubesteller controllers currently use KubeFlex to get their kube configs for the relevant spaces, but they could potentially get them other ways. That would be a small change. So KubeFlex is something that can provide multiple kinds of space. It's something you deploy KubeFlex in a Kubernetes cluster, and it provides what it calls control planes, and it has a few kinds. One kind, K8s, it's based on Kube API server and the Kube controller manager with most of the controllers disabled. Again, keeping only the generic controllers enabled. So it's as blank a space as we can easily arrange with the current available code base. So kubesteller commonly uses these for workload description spaces. Another one is a vCluster that uses vCluster to provide a whole hosted cluster. Kubesteller commonly uses these for inventory and transport spaces because it also runs the transport controller in the hosted cluster. Another kind of control plane in kubeflex is called host. It's really just an alias for the cluster that kubeflex is running or hosted in. Another kind is external, which is just a reference to a general other cluster. And we have hoped, for a long time that CAP 4080 will come to fruition, and we can build a truly blank, space or API server, as was talked about in last week's meeting. All right. We do, as I said, have an architected distinction or separation between the upper layers and the transport layers. So we think of a transport as being a service provider interface. So the interface is in terms of two things: binding objects and work status objects. A binding object has a list of references to workload objects and a list of managed clusters. And a work status object has an abstract of the information about propagation and reported state from one particular workload object in one particular managed cluster. And this separation is still a work in progress. It's not totally complete. So in particular, the inventory should be more abstract, but right now it is. What is that?
You're getting a spam call now.
Okay. So currently we just use OCM managed clusters directly for inventory. All right. So architecture, basically two parts. At the upper layer, we have a binding and status controller that resolves binding policy objects to binding objects. So it resolves those predicates to concrete lists and combines the work status objects to create the reported state to do the reported state aggregation, and it does the one-to-one reported state return in the cases where it's requested and possible. And then at the lower layer, there's a transport controller. It reads the binding objects and the workload objects and maintains manifest work objects, which then OCM handles. And then there's a so-called OCM status controller, which is an OCM add-on that is the thing that maintains the work status objects. And let me go and show you some more pictures here. There should be multiple inventory and transport spaces drawn here, but the idea is users then deal with their inventory and their workload descriptions, and then the kubesteller stuff makes it go to the managed clusters. A little more particularly, as I mentioned, we've got the various controllers. There's the upper layer controller dealing with the bindings, the lower layer transport controller, and then the space manager kubeflex itself. Again, we're dealing with the managed clusters, have the usual OCM stuff plus the add-on that we've got. Let me briefly show you a little bit about APIs and examples, and then stop for questions. I'm not quite sure what I should do about thinking about time here. Let me just maybe I'll just show some examples here. No, let me go.
Now.
Okay, let me go show the API. Let's see here. Yeah. Okay, so API. Let's look at binding policy. Maybe here we go. Binding policy. Okay. So a binding policy, the spec of a binding policy is basically two lists, clusters selectors that selects the what, and then the downsync is talking about where. We did originally have upsync as well, but going to OCM kind of rubbed that off.
Can you zoom in a little bit?
Oh,
There's a request for that in the chat. Thanks.
Absolutely. Let's see here. Okay.
Thanks.
Yeah. All right. So a binding policy has two things. It's basically the what and the where. First is the where. So cluster selectors, that's really simple. That's label selectors on the managed cluster objects in the inventory space. Currently in a WDS, the binding policies go in the WDS. Currently a WDS has only one associated ITS. So this is really simple. It's just a label selector for the managed cluster objects. And then the downsync is in terms of downsync policy clauses, which has two things. There's really the selector and then a little bit of modulation on moderation, modification, mode bits about how the downsync is done. And there's really, so here, let me just first go to the selection. So this is basically a test on the API objects, and it's just a bunch of conditions on the object itself. So you may or may not choose to care about the API group. You may provide a list of resources within that API group or not. You may restrict by namespace by listing the individual namespaces or have a label selector on the namespaces. And similarly for objects, you can use a label selector for the individual objects or list the names or not care, just take all of them that match the other criteria. This again is a conjunction of criteria match sort of predicate. For the modulation on the downsync, we do have this thing called create only. It's really kind of a special case of a more general idea, which I won't try to go into here about, so I'll just stop there, right? Status collectors, this specifies how the returns reporting state should be aggregated. And then also this is a request for that one-to-one kind of a reported state return. As I said, in the case of an object that goes to only one managed cluster, you can request one-to-one return, which means that the reported state for the managed cluster, which is normally in the status section of the object, gets copied to the status section of the object in the workload description space. So that's a binding policy. Let's see, now let's go to a binding object.
I think I can give you like 5 more minutes, including questions. Right. So just FYI.
Okay, let me stop here. I'll stop here and take questions then.
Sure. Bobby, I see you have a hand.
Yeah, I was actually wondering how users specify intent for placement on multiple clusters, which I think that's in binding policy. Is that right? And
yes.
That's my first question. So the second question, it seems like binding policy is more of a static way of specifying placement. desire for placement, but is there any other way that the system maybe monitors at runtime dynamically, reacting to runtime events to place
Oh, yeah.
workloads
Well,
in?
the controllers here, they're regular Kubernetes controllers, so they react to changes dynamically.
Okay. And what? So because in a binding policy, I didn't see a whole lot of ways to specify that. What are the events that the controllers react to? For example, if a cluster goes down, does your controller detect that and place the workload on a different cluster?
So as I said, this is not a scheduling paradigm. This is a management paradigm. So the
Okay.
policy says what goes where. If a where can't be reached at the moment, this is a normal Kubernetes controller. So it'll keep trying. And if and when the managed cluster becomes available again, then stuff will happen.
I see. Okay. Yeah. Thank you.
Go ahead, John.
Yeah, so my question was a little bit more about the policy side, because as you say, it is more a management paradigm rather than a scheduling paradigm. Would that mean that, because I haven't gone in depth into a kubescaler yet, but would it be similar to say how you have topology constraints or affinity or stuff like that, where you specify your constraints ahead of time, and the controller will just use events without having to change the status or without having to change, but still be able to have your changes, or not necessarily changes, but have your workload get rematched to the correct cluster. To say it was matched or it was provided, the workload was essentially running on one cluster, the cluster goes down for some reason, and will kubesteller then recognize that the situation has changed, and as such you redistribute the configuration?
Yes. Maybe I should say more clearly and directly. We take an eventual consistency based approach here.
Yeah.
The users may be, or whatever higher level software may, make whatever changes to the inputs at any time, and kubesteller reacts as best and quickly as it can. Obviously, it can't do the impossible, but it does what it can. I should mention there's one kind of interesting difficulty here, which is kubesteller does consider itself an add into your environment. So when it puts an object into a managed cluster, for most kinds of objects, it will mark that object as being managed by kubesteller, or maybe even relies on OCM to do that. And so when kubesteller stops wanting that object to be there, it will be retracted from the managed cluster. But there are some interesting cases for context setting objects, in particular namespaces and CRDs, which might already be present for other reasons. So one of the debates and difficulties we have is, how do you know whether a namespace is there only because kubesteller wanted it there, or also because something else wanted it there? So currently, for example,
sorry for interrupting, but that's exactly what I was after indeed, because it seems like the flow of change is unidirectional and the status is surfaced. But yeah, if you declared your intent for a workload to be compatible with some cluster, the cluster was there and then the cluster goes away, is the cluster or a resource in the cluster, is it gone because you wanted it gone, or did something else share that resource and did it make it go away? Similar to Terraform, where you almost always need a three-way diff of your known state, your actual state, and your desired state.
So as I said, the approach,
if we're still there.
Right. So the approach we're taking is that for the context setting objects, specifically namespaces and CRDs, we suppose that they might be there for other reasons. And so kubesteller doesn't delete them. For the other kinds of objects, kubesteller will mark them as managed by kubesteller and delete them when kubesteller no longer wants them there.
All right, thank you.
Mm-hmm.
All right, we got time for one more question. So Lee Chun, go ahead.
So I would like to learn more about what you mean by 101 status or aggregate status. If I place a deployment to multiple clusters, what will those status look like?
Right. So the one-to-one case well, you ruled that out, right? The one-to-one case is when it goes to one managed cluster. For the mini or general number of clusters, since we're short on time, I can only offer you pointers to follow. But we have defined an aggregation, a way of expressing desired aggregation of reported state and propagation in reported state. And so we have defined maybe I'll just briefly flash it for you here. If I can, let's see. You know what? I was just trying. Well, I'm sorry, but we have defined an aggregation, something that looks like SQL grouping and aggregation for defining. You basically users define how propagation and reported state should be grouped and aggregated into report objects in the workload description space. Maybe I'll try to. Let's see. Yeah.
So in like, for example, in group by, if the conditions are all different, how do you aggregate?
I'm not quite sure I understand the question.
Yeah, I mean, like, if you group by something, right? Like, if the values are all different for a certain dimension, how do you aggregate? Do you merge them as a list? Like, for example,
I see. Yes. Okay.
State.
So right. So the combined the aggregators that we have defined are just the ones from the numeric ones from SQL, basically. So we can combine numeric fields. Also, it is possible with anyway in SQL, to get lists where you want lists by doing that in the grouping rather than the aggregation.
Okay, thank you.
All right, thanks so much for giving the talk and scrounging through lots of API to answer our questions while talking at the same time, chewing gum and walking at the same time. Great job. Okay, I'm going to move us on to Mike and Ryan. You have a agenda item about placement decision API proposal and demo.
Right. Can you, I'm going to share my screen. How much
Yeah.
time do I get though before I get started and pace myself?
Yeah, I think you can have 10 minutes.
Okay. So I'm going to go quickly. So placement decision API is kind of like my desktop, minimalistic, straightforward. And that's what me and Ryan are trying to propose to the SIG community. We want to introduce a new standardized API that shows only the outcome of the results of a placement and a scheduling decision. The main reason we're trying to do that because we feel like the scheduling and the placement spec might be quite contentious and quite controversial and require a lot of discussion. But before we get to that point, maybe we can have the placement decision API so the consumers can already have a vendor neutral API to select. So those consumers might be like GitOps engine, requested delivery, IML pipelines, and then they consume the placement decision and kind of eliminate the needs to interpret many different multi-cluster solutions when it comes to scheduling. So again, it's on purpose to be minimalistic in design, status only. There's no scheduling spec or requirement logic, so it's outcome only. And then the cluster entries are supposed to map directly one-to-one with the cluster profile resource name. It's a namespace. We're proposing a namespace scope resource. The namespace, of course, maps to the cluster profile as well, which is again a namespace scope resource. So it's really for simplify the adoption for consumers, so they know where to schedule their app or workload in the multi-cluster environment without having to implement their own scheduler. So some diagrams, some pre-charts. So we have this diagram in the above recently in the SIG MC showcase multiple parts of the what combines into a hub cluster or a central kind of like the brain multi-cluster control plane, that type of cluster. So this placement decision API falls under the scheduler part. It is the decision, again, is the outcome, and it's not the actual placement API itself. The placement API is the actual scheduling spec. So placement decision is mostly the outcome. So in this case, the scheduler or the placement API controller will write the placement decisions, and then the consumer of the placement decision will read the status, the list of clusters, the set of clusters that the placement decision contains, and then they'll action on those targeted clusters. So the goals I already mentioned. So let's talk about the non-goals. Non-goals, again, we're not talking about the scheduling side, the placement spec. We're not going to define how to access those clusters. The clusters are listed on the placement decisions. We're not going to provide orchestration logic. It's mostly data only. And it doesn't replace the syncer or the work API, which is actually responsible for applying the manifest into the target clusters. So here's an example of a placement decision. I'm gonna get into a demo later. So in the placement decision here, under the Argo CD namespace, there's a slice -1, and here's the link that links all the placement decisions together. They all fall under a placement. We don't have this API yet, but this is just trying to say all these decisions, all these related decisions are under this specific label. This allows the consumer to select it through a label lookup. So again, it is only a status. It holds the list of resources. So currently we're designing to not have intentionally omit the spec, so that make it obvious that it's not to represent a desired state. It's intended to be written by the multi-cluster solution provider, or the scheduler through the status updates, and then read by the consumer, who treats it as a data read-only object. So in the decision here, it kind of shows the cluster name, which must match with the cluster profile name in the same namespace, and then the reason, which is optional notes on why this cluster was chosen. And then there's each slice of the decision is up to 100 cluster decision per object to avoid ETC limit. I'm gonna get to that in details next. So why is in slice? So we're following the pattern of the core API endpoint slice. So similar to services have a bunch of can have multiple endpoint slices to support large scale amount of services endpoints. So we're following that convention, so to speak. So each placement decision can contain up to 100 cluster decisions, and then which keeps the object should be well below the 1 megabyte ETCD limits. So again, all the related slices, so all the related decisions related to a placement needs to fall under a common label. So far we have it as this, so that the consumer is expected to look up all the placement decision through the label selector instead of directly getting the placement decisions. So some of the use cases, obviously the GPU AI, where AI training. So the scheduler might rank the available clusters by GPU and cost, and then they'll update the placement decisions, and then the syncer work API, Argo CD, will actually deploy the job to that target cluster. I mean, it can also use for progressive rollout. So some progressive rollout controller manage the rollout, and then looks at the placement decision for kind of like a step-by-step decision. And then also can be used for disaster recovery. So some controller can place a decision, look at a decision on which is the available clusters, and then if it ever changes, it can be able to fall back and then deploy onto the failover cluster. So we already have, the nice thing about this placement decision API is we sort of have a pseudo adoption already through Argo CD, which I'm going to quickly do a demo of now. And it uses the Argo CD application set cluster decision resource generator. Again, that generator will use this to label lookup, and then which unions all the placement decision. And then I guess I didn't mention that in the very beginning. I have the detailed doc proposal written in here. If you the doc, the presentation, and the demo link are all linked in the SIGMC the work doc that we have. So feel free to please check it out. Shout out to all the participants for helping Roy and participate in the in constructing that document. So I'm going to do the placement decision API that we're proposing with Argo CD. On the left side, I have the hub cluster. On the top right and bottom right, I have the cluster 1 and cluster 2. So I will apply first the first apply the placement decision. So let's go. So QCTL doesn't apply the status. I will have to manually use the patch to make it so that it has cluster 1. So this gives the placement decision cluster 1, and now I'm going to apply the Argo CD application set. The Argo CD application set again is looking at the label selector, the app placement, which is the decision there. So when I apply this, so I should be able to see the guestbook. So we can see the guestbook is in here, and it's not in the cluster 2. And then if we get we can see the resources are being applied, and we can do this dynamically as well. So if I go like, so if I go cluster 2 here, and then the Argo CD should adjust the deployment from cluster 1 goes to cluster 2, which has the, and then also we can do a get all. So this will goes to cluster 1 and 2, and then so wait a little bit for it to reconcile, and then we can see that. So Argo CD is already consuming the placement decision and making based on the decision, making the right deployment there. So that was a really fast, high level presentation with the demo. So please feel free to continue to participate in the doc, and then if it's something that the community thinks is pretty good, I'll go ahead and create the kit for it. But before that, any questions? So regarding the placement decision proposal?
We have one still valid question in the chat from Lee Chen about the decision being one-way communication. Could decision executors provide feedback, like whether it was even able to execute the decision back to the scheduler? Is that in scope or a thought?
Sorry, could you repeat that? I don't want to.
Oh yeah, sure. Lee Chen, do you want to ask your question?
Sure. So it seems this scheduling decision is one-way communication because you directly use the status. No one is able to update the status.
No, the provider can update the status, right? So the consumers are watching.
I know. So the provider basically updates status. Then no one basically owns the spec now. So that means it's basically a one-way communication, right? Like I made a decision, then here's the decision. I will notify you, but you cannot talk back, say, oh, your decision does not make sense, or I cannot execute it. So that means there's it's impossible for the scheduler to do something like rescheduling if the decision cannot be executed. So I was wondering whether it will be useful to add a two-way communication so the consumer can also talk back to the provider about their follow-ups.
That's a great feedback. Yes, I will definitely put that in the doc, and then we can, that's a long topic. We can discuss more in the doc or in Slack. No, that's a great feedback. Definitely gonna consider. Thank you.
Mike?
Yeah, I see a consistency, Vaughn, in your questioning here. I would say that from the point of view of this placement decision, the question of whether it can be executed is really, it's a bigger question, right? It's not just the placement decision that goes in. You'll see, and in Kubestellar, with the combined the various kind of ways of returning for the state, you can get that kind of information back. And I should say again, we do have some examples of list-oriented aggregation or returning, combining reported state. So yeah, I think that's. I'll just say I think I hear you.
Thank you.
Cool. Sorry to cut this short, but thanks for the demo. Looks like there's a lot of progress going on in this, and thanks for sharing it more broadly. And everybody, please take a look at the doc, and maybe we can keep talking about this in the future as well. Sounds like it's going to be cool. We just have a few more minutes, but I do think the next two items are like a little bit admin-y, so maybe that's fine. Bobby, you want to go first?
Sure. The idea is the same. We talked about adding a committee for approving PRs or, going over those PRs for the first pass before before our leads, SIG leads can approve them. So this is basically, I don't think there was any objection to the idea. I saw a few plus ones in the doc, but we didn't hear any objections. If anybody has any objection, please say something now. Otherwise, maybe we can move forward with identifying these people. I thought that maybe we can have an online form where volunteers can submit their desire to be in this committee, expecting them to spend about 4 hours every week to review PRs, address comments, etc. And then I guess Honkai said that there is a way to, or maybe another process to choose tech leads. I followed the link. I didn't see any particular way to choose them, but there is like this concept of tech leads in the SIG as well, which maybe these people can act as tech leads. That's for sure. I don't know if there is any other better way to pick these people or not. Otherwise we can maybe go with the online form and then let SIG leads. If there is more volunteers than we need, then maybe SIG leads can choose among the volunteers.
Cool. Yeah, I think for me, it's less about, there's an aspect of finding people who are interested, but then I think the next part is about like how and who is wrangling them, I guess, which I think is maybe the bigger maintenance sustainability issue. So I think we have to, handle that at some point. But I think in terms of like collecting interest, I think getting this form is like a super valid way to make it easier for people to self-identify themselves and give us a way to at least communicate with them more formally.
Agreed.
Yeah. Okay. In that case, then, to everybody, please go ahead and take a look at that form and submit that form if you want to be a volunteer. And I'll share the results with Jeremy and Stefan.
I haven't clicked on the link, but is it topic related somehow?
Which one?
I don't think so. I think it's just like you're a person. So maybe if you want to add, Bobby, one more thing in here that's like, what are your like review or component area interests? That I think we might be able to determine that because we know several of these people who are already involved, but that could be another piece of data you could capture.
Said it again. What? Capturing the
Oh,
component that they want to
yeah,
review?
yeah.
Okay.
Arthur is asking, like, is there a place where I could say, for example, I want to review MCS, or I want to review about, or I only want to work on this component, or I have expertise in this component. I think
I
that's where
think that's a good idea, adding that.
Okay, sure.
All right, we're over time. I'll leave this item to be read. Let's meet again next week, shall we? All right, thanks for coming, people. Bye.
See you then.
Bye.
Thanks. Bye.
Thanks.